Hi, a very good day. My name is Vien, leader of IDP Group 9. Today I'll be presenting my group's integrated design project, which is Smart Custom Transporter with efficient multipurpose towing rigs, under the supervision of Dr. Mohamad SANI Mohamad HASHIM. So first thing first, what is a transporter? Transporter is a mechanized vehicle that is used to transport goods or people from one place to another. What is towing rigs? Towing rigs is an external containers introduced as part of the transportation to transport heavy and large objects. What are we building? Basically, it's a combination of a two-wheeled vehicle and a towing rig, which is also known as trailer. Who is our target? We converge our interest in the agriculture sector because in 2013, this sector contributed more than 23% of the total export earning and added about 7.2% to the Malaysia's gross domestic product GDP. In addition, our main focus will be on small-scale plantation owners, which is the farmers. Why do we choose small-scale farmer? First of all, we have to pinpoint that it will be a heavy burden and too costly for a small-scale farmer to purchase a four-wheeled transporter, like the ATV or a truck, to move their produce. Besides, is to improve their overall productivity while at the same time increasing the number of produce. Next is the problem statement of our project, which is the increase of ideal agricultural land due to labor shortage. While the second problem statement of the project is the increase of production costs. And last but not least is the low productivity of the produce. So now we have come to the objective part, which is to design a smart transporter, then to explore the mechanism of several existing mechanisms of the rigs, to design and optimize the towing system for the smart transporter, and to test the reliability and functionality of the smart transporter. So now we will be discussing on the scope of the project. In this project, we are using two-wheeled transporter. This is because two-wheeled transporter is more convenient to use in narrow space roads and in general cheaper than the four-wheeled transporter. Besides, in this project, we will not be including the engine in our two-wheeled transporter, as we will be focusing more on the usage of the multi-purpose towing rigs. And lastly, from me, we will be looking at a simple animation video about the basic functions of towing rigs. Hello everyone. This video presents the smart transporter and the multi-purpose towing rigs. In this video, we will be focusing on the functionality of the multi-purpose towing rigs. These multi-purpose towing rigs will be towed by the smart transporter. This multi-purpose towing rigs is used to carry the plantations such as vegetables, fruits. These towing rigs are also detachable from the smart transporter. Once the towing rigs is getting overload, it will produce sound to alert the user about the overload condition. The behind of the towing rigs also can be opened to make it easier for unloading process. That's all from us. Thank you for watching.
Assalamualaikum and hi, my name is SHAHADAH binti NIZAM.
Next, I will be presenting on the methodology of our project. We have done a market survey analysis, which is to analyze the type of the transportation that fit in the agriculture. And there is a few design of the smart transportation in the market, and it fit the functionality and requirement of the customer need. And also we have find and research a transporter that fulfill the performance, cost, ergonomic, safety, ethics, sustainability, and environmental element. As we can see on the screen, there are two-wheel and four-wheel transporter where the element is quite different, where the two-wheel transporter is cheap and four-wheel transporter is expensive, and the two light transporter can move like the load, and the four-wheel transporter can move heavier load. Also, in terms of ergonomics, the ability to ride through narrow roads go to two-wheel transporter, and the four-wheel transporter unable to ride through narrow road, which is not good, as we know that farm always have a narrow road and unstable road. So in terms of safety, the two-wheel transporter is less stable, but it's quite quick in transferring anything. And for four-wheel transporter, it is more stable, but it will be take more time. Also, a few more elements that compare these two products. A survey has been done to collect the information from the respondent. So we have distribute the survey by distributing the questionnaire to the respondent in order to complete our product research. So for the first part of our questionnaire, it is consisting of a demographic profile, which is question that the respondent age, gender, and race. Then the next question, we ask about the smart transportation, where we focus on the design that have eye-catchy, easy to handle, and low cost to satisfy the need. This is an important part where the respondent need to make a choice between all these factors. And also, there is a question that asks the respondent to choose the most preferred transporter, either four-wheel or two-wheel transporter, that are more suitable to be used in the farm. So, and the last section of the survey is focusing on a smart towing grid system. So we are focusing on the problem that our farmer facing in their farm with the solution to the design of transporter. For the conceptual design, we have generated all the ideas through a few stages of functional and physical decomposition. By doing this, we have continued the process with a few morphological card, context diagram, and we do the calculation of the physics design and design parameters in order to get the stability and the correct calculation for the transporter. And also we do the design parameter and constraint before we come out with the final design of the product. The design of the transportation is focused on functionality of the smart transportation in order to make the farmer easier in handling their product. We also want to solve their problem with just this one of our design. So all the specification for the transport, such as handle, absorber, tire, transport cushion, are taken care to ensure the comfort and stability of the transport while the process of took out the product from the farm. This is a very important factors, because people will buy the product from its outer design, and also by its amazing functionality. This is our final concept drawing. Before we decide the concept, we had consider the design parameters, the product design specification, the concept generation based on design. We also consider the design goal and constraint. We calculate all the physical decomposition and another few factors. We have done the each stage, and the final concept design is what we can see on the screen. It is selected as the final design as it has a higher value which we obtain from the AHP. We have calculated the value, and it shows the highest value which is suitable to do the product and the design. So in this case, the transporter will be attached with the suspension fork to provide the stability when encounter the uneven road. as we know that in the farm the road will not be less stable and it will be a narrow, so this will help provide the stability. And the seat on the transporter is designed for this concept. We designed a padded seat which will give a lot of comfort even in a hard work while transferring the product out of the farm. And the upper part of the towing rig for this project is built from a net, which means this towing rig will quite a lightweight, and there is also 4 wheels that attach to the towing rig, which allows the towing rig to move stably. And also the important concept design is we have fulfilled the customer requirement with our design, as the farmer need to transfer their product in a less time and in a bigger quantity. So with our design and our calculated uh, element, we are sure that the problem can be solved. So that's all for our concept design.
My name is AVEERUDTH. I am from Art K08 Mechanical Engineering Program.
Here is our CAD design for this project, which is the smart transporter and the multi-purpose towing rig. The multi-purpose towing rig is attached to the smart transporter by using a connector rod, and this multi-purpose towing rig is also detachable from the smart transporter. This smart transporter design will be based on the lightweight design, and the material that will be used for this structural analysis is aluminum alloy. The reason that we use aluminum alloy is because the material is easy to undergo welding to form the shape of the chassis, connector rod, and towing rig's body, and it's also easy to cut. At the structural analysis, we will analyze on the load of human sitting on the chassis and engine. We will put on the chassis the pulling force for the connector rod and the load that was put on the platform of towing rigs. In this design, we decided to avoid to do the analysis on the net because the material that we choose is elastic and is hard to undergo the deformation test, so we decided not to proceed with it. So here is chassis analysis. So in this analysis, we will consider the load of 80 kg of human will be sitting on the upper part of the chassis, and at the lower part of the chassis, we're going to put load of 20 kg of engine at there. So basically, the force that we acting on the upper part of the chassis is 784.8 Newton, while the force that we acting downward the lower chassis part is 196.2 Newton. And the result that we obtain after we assume the condition, we can see that the maximum deformation test that we obtain is 5.826 exponent negative 5 meter, while the result that we obtain for the strain test is 5.3067 in the power of negative 3, and there is no minimum value for deformation test. For the strain test, we got the minimum value is 4.57 exponent negative 19. Okay, now we are going to platform analysis. In this analysis, we will consider like we putting load of 150 kg on the platform, which we consider as a force of 1,471.6 Newton acting downward on the surface of platform. So for this test, we get the value for the deformation test. It is 2.029 exponent negative 8, and the strain test is 1.2731 exponent negative 6. There is zero. There is zero value for the minimum deformation test, and for the strain test is 3.5276 exponent negative 7 minimum for the minimum value of strain test. As we can see from the deformation test, the platform start to deform at the corners of the platform, which the four corners basically of the platform, because we can see the red color is formed at them. So this is the connector rod analysis. So for this analysis, we can do deformation test and strain test also. So for this analysis, we're going to assume the force 2500 Newton is acting on the y-axis. Okay, so from the deformation test, we can see the deformations start to occur at the right end point of the connector rod, while for the strain test, the maximum strain occur at the left end point of connector rod. So the maximum deformation value that we got from this test is 1.787 for exponent negative 5, while the maximum strain test value that we obtained for this is 1.2301 exponent negative 4. For the deformation test, we didn't have any minimum value, but for the strain test, we obtained 5.59 for exponent negative 5. And that's all for me. Thank you.
Assalamualaikum and hi to everyone. My name is ZAFRI bin Abdul Ghani. For the motion simulation, I will explain and show you the visualization on how the smart transporter and the towing rig is moving. I will also show you the detachable between the smart transporter and the towing rig, bolts and nuts from the isometric view, the left view, right view, top view, bottom view, front view, and the back view. Okay, this is for the towing race. The motion simulation I'll test at the tire, so I will show you the video. You can see the tire is moving. This is from the isometric view. This is from the back view. From the front view, this is from the left view. From the top view, from the bottom view, and this for the isometric view. So basically the movement of the simulation is exerted based on the force and the speed from the smart transporter. And next I will show you how the smart transporter is moving. This is the video for the smart transporter. We can see the tire is moving from the left view. This is from the isometric view, and the tire is still moving. You can see that. Yes. Okay. The tire is moving. This is from the top view. And this is from the bottom view of the smart transporter. So next, I will show you the detachable of the smart transporter and the towing reach. How the bolts and nuts will detach the smart transporter and the reach. So I will show you the video. Okay, the bolts is pulled out, the nuts is pulled out, and we can detach the towing reach from the smart transporter. This is the visualization of the detachable of smart transporter and the towing reach. And this for on how to attach back the smart transporter and the towing reach. And next, for the bolts and nuts, I will show you how the bolts and nuts can pull out the towing reach and the smart transporter. You can see that the nuts is pulled out. Is pulled out by the person or man. So this for the motion simulation. Basically, the motion simulation is provide a complete and qualitative information about the kinematic, which is including the position, velocity, and the acceleration. And for the dynamic is including the joint reaction in the internal force and the power requirement. Next, I will explain about the sustainability. Sustainability is referred to interaction in usage throughout the service. Design for sustainability is a systematic, streamlined, concurrent engineering program in which sustainability engineering weave into the total development cycle. It relies on the array of sustainability engineering tools along the proper understanding of when and how the use of tool throughout the design cycle. This process encompasses the variety of tools and practices and describe the overall development that organization need to follow the design sustainability into the product. The importance of sustainability is for the environment quality and for the growth. For environment quality, in order to have healthy communication, uh, uh, in order to have healthy communities, we need to have clean air, natural source, and non-toxic environment. So, the smart smart transporter and the towing reach, we have to make sure the usage of the smart transporter will have the clean air, the community will have the clean air, natural source, and non-toxic environment. And second important of sustainability is growth. To continuous the growth, so we need to require more resources such as energy, water, and space. Which is the sustainability is aimed to use our resources to benefit for our environment and towards the community side. Okay, next for the ethic. Ethic is a set of principles that decide whether something is good or bad, or right or wrong. In terms of engineering, the ethic is related to moral ideas, policies, relationship of people, and the organization itself. One of important aspect of ethic is very important is safety. Is that the product is safe to our public, and we have to confirm is that the product will not bring any type of danger or safety issues even if the product has systematic and operating problem. The product also will not bring any harm to environment as the purpose of the product is for the greater good of the environment. And last but not least, I will explain to you the impact of the product towards the environment and the society. So we can see from the picture the silo, which is the Mickey Mouse bracket, view of the relationship between the economy, environment, and society. Society, we can see the diagram here. Okay. Next, the Venn diagram is triple bottom line. This the view of relationship between the economic, environment and society. So the society, economy, environment is is correlation between itself. And lastly, the system view sustainability, view of relationship between the economy. This is the picture about that. So mostly the development of this product brings several good impact to society and the environment. Usually in agriculture field, they would use a big machinery or truck to solve their plantation problem. So with the purpose of smart transportation system, uh, we can ensure it also can help the plantation purpose. Thus, the making will make more ergonomic, they save more money and the fuel consumption to the agricultural field. So that's all.
So, hi, Assalamualaikum. My name is NORATIQAH binti MUHAIDIN. For cost to build up this product, initially we have made a survey to find out the range budget for this smart custom transporter. And most of the respondents agreed to invest the budget up to RM3,000. But to get the price range for each part of the component, we have made a price survey around the workshop and vehicle accessory store around PERLIS. For Smart Custom Transporter, the price that we get is around RM1,775, while for the towing rig, the price is around RM177. If we total up for these two parts, we will get around RM1,952. Based on these two parts, we get a profit of around RM1,048. Okay, next is I would like to explain about the net profit and margin for our project. Okay, net profit. Net profit is the total profit that we get from our project. To calculate this profit, we use the formula of gross profit plus with total income and minus with total operating expenses. For our project, we get the net profit around RM58,800. Next is gross profit margin. Gross profit margin is the profit margin that we get from one product. To calculate this gross profit margin, we use the formula of gross profit per sales amount times by 100%. And our project gross profit margin is around 34.93%. Then last one is I would like to explain the profit margin ratio. Profit margin ratio is the profit that we get for our whole product. For this project, we use around 50 products, and to find the profit margin ratio, we use the formula of net profit per sales amount times by 100%. And for our project profit margin ratio, we get around 39.20%. In conclusion, from this project, we get to know about the technological advancements in the mechanical field in produce efficient transportation. As a component of developing smart cities, greater integration of advanced vehicle technologies is commonly discussed, potentially leading to a lot of benefit. From this project, we have achieved our objective, which is to produce a design for agricultural fields. Next is to explore the mechanism of the smart transporter, which is the knowledge of the mechanism of the smart transporter. There's a lot of changes that we can do in order to ease our daily life. And the last one is the reliability and functionality of the smart custom transporter have been tested. Okay, the recommendation from this project is, as we know, smart transporter is one of things that had caught attention of researchers lately. From this project, recommended that there will be more reforms, incentive, and exposure that can be applied in the agriculture field, especially for the smallholder farmer. One of reforms that can be done is to add additional application such as watering and fertilizing using this smart custom transporter. Therefore, preferably, there will be more programs that can be held for smallholder farmer so they can be more exposed to advanced technology to facilitate day-to-day works.